Well, welcome back to type 2 binary ionic compounds. The last time we did this video, we were looking at type 1 binary compounds, and you may be asking yourself, well, what's the difference now? The difference is with the type 1, we were able to very clearly see the different oxidation numbers that were being used by these particular elements. For example, we knew that group 1, it has not only an ionic charge of a 1 plus, but also has an oxidation number of a +1. Okay, so now we're going to learn a little bit more about what these oxidation numbers mean. So these are very clear, and these are also, we always know that any type of element that's found here in group 2 is always going to have a +2 oxidation and a +3 and +4 or -4 and so on, -3, -2, -1. Those you can count on. Okay, with the type 2 binary, we're dealing with a lot of them here in this, I remember the d orbital, these elements right in here. Some of them carry more than one charge. Okay, so we have to look at these different oxidation states as a result. Now, to help us to distinguish between type 1 and type 2, we will be looking at Roman numerals. So if you see a Roman numeral, that is a good clue that you're dealing with a type 2 binary ionic compound. So why would we need these Roman numerals? Well, that's because some of these metals carry more than one charge. For example, gold. Sometimes gold you can see as a +1 with an oxidation number, and other times it's going to be a +3. Okay, so we need to find out how these are working here. So if you look at the Au and the Cl, well, the Au and the Cl, they're in a 1-to-1 ratio with one another. Now, we just said that chlorine, we know, is a -1. That's never going to change. Okay, so that helps us when we're doing some algebra here. So since that never changes, we can count on this. We can put a -1 right here. Okay, so if these came together in a 1-to-1 ratio, that must mean that this was a +1. Okay, so we would write this as gold with a Roman numeral 1 chloride. Okay, that's how we would do that. That means that this has two different oxidation numbers. It just so happens that this one we're dealing with a +1. Okay, now let's look here. If you see AuCl3, we know that chlorine is always a -1. If it took 3 of those to happen, then what must this charge be? It must be a 3+, right? So you have your 3+, and then you have your -3, that equals 0. That's what we need here. Okay, we need that net overall charge to be a 0. And so how would we name this? Well, we're going to name it gold. It must have been gold 3. Okay, that 3 goes with the metal. Okay, gold 3 and then chloride. Okay, so let's take a look at a couple more of these. These are some common metals that can form more than one oxidation state. Okay, so iron could be as a 3+ or a 2+ whenever we're dealing with its ionic charges. Okay, so therefore it could be iron 3. Notice how they're in Roman numerals, or it's iron 2 if it forms a 2+. Copper can also form a 2+ or just a plus. So distinguish between the two, we would put copper 2 in Roman numerals or copper 1. Now these are the older names that were given back in the day. This is the newer way. However, there are going to be, sometimes if you ever work in a lab, some of the elements are old. This happened to me a lot whenever I was working in a chem lab in college. It would say things like cupric. I wouldn't have copper 2, so I had to know these old names. So it's also a good idea for you to understand these names too. Generally speaking, if you see an us, it's in the lower oxidation state than if you see an ic. Okay, so this is, iron can form a 2+ or a 3+, so ferrous would go with the lower number, and ferric would go with the higher number of the two that they would form. Notice with copper, notice there's just a 1+ or a 2+, so the cuprous goes with the lower oxidation state and cupric would go with the higher. Okay, cobaltous, I know it sounds kind of silly, and then cobaltic. Okay, but those are the older names. This is what we use today. but you will see them both, so make sure you're familiar with both. So this, since it's a 3 plus, would be cobalt 3. So just kind of look for these Roman numerals. Tin can not only be 4 plus, but can also be a 2 plus. Okay. Again, stannous would go with the lower of the oxidation numbers between the two. Stannic would go with the higher. Lead is another one. It can either form a 4 or a 2. So you would have Columbus or Plumbic. Okay. And then mercury 2 or mercury 1. Now these are some common ones. Of course there are others, but these are just some common type 2s that we will be dealing with, okay? And to help you along, just make sure you understand your algebra and to make sure everything balances out to 0, and you should be just fine with these. Okay, so sometimes you see these Fe2O3 and you might be wondering, okay, well, which charge is which? We call this the crisscross method. So first you're going to write out your element symbols with their oxidation numbers up on the top, okay? And then you're going to try to find out what their common denominator is, so to speak, and do some multiplying so that they will all average out correctly. Now, the best way to do this is just simply to crisscross them, flip them around. If you know here that there is an Fe2O3, well, if it took 3, we know that oxygen is a 2 minus. How do we know? Well, we said that some of these are very nice to us. We know that everything in this group is a 2 minus, okay? And that helps us. And everything here is a 1 minus. So knowing some of these are very helpful for us. So let's go back now to this one right here. So if we know that this is a 2 minus, we can kind of work backwards. So if it took 3 of these with this 2 minus, then we know that 3 times minus 2 basically is a minus 6, okay? So it must mean that this must have been a 3 plus, right? Because a 3 times 2 here would have been a plus 6. Plus 6 and a minus 6 equals that 0 that we're looking for, okay? So what you can do here is, if you know this, you would take the O with the 2 minus and stick it here. We crisscross it, okay, and this 3 here would go down below. So they just kind of switch charges, so to speak, okay? You could do it this way, just crisscross them, or you could do the harder way that I just showed you, find a common denominator and make sure everything balances out to 0. Okay, so once again, just looking at this, I guess the harder or the longer way, you have, we know that this is a 2 minus. It took 3 of those, so 3 times a minus 2, or you take the 2 times this plus 3, everything comes out to 0. Okay, so make sure that they're always a net overall charge of 0. All right, let's give these a try now. Okay, so it always helps whenever we know what some of these charges are to help us find this missing guy over here. Okay, so we know that chlorine is a -1. That's easy. So if they're in a 1-to-1 ratio, what do you think that this would be? Well, hopefully you said a +1. So we need to write this as copper 1 chloride. Okay, you're going to see some Roman numerals today. Okay, now this one here. Well, they're in a 1-to-1 ratio, and some of you might, if you were thinking you're doing the type 1, you might think, oh, this is just mercury oxide. Well, we don't know what charge this is, because we said back here that mercury can have different charges. Is it 1 or is it 2? Well, let's go find out which one it is. We know that oxygen is a 2 minus. Thank goodness for some of these guys that help us out here. So that must mean that this is a 2 plus. Write down these oxidation numbers up on the top to help you out. So we have to say that this must be mercury 2 oxide. Okay? Because it took 2 to equal that 2 minus there. Okay, this is going to be another crisscross. I know that this is a 2 minus. That's where this comes from. So this must be iron 3, okay? So iron 3 oxide. Okay, so again, this isn't a 1-to-1 ratio. This is a 2 minus, which means this must be a 2 plus. So this one is going to be iron 2 oxide. Okay, now this one might be a little bit interesting here. Notice we know this is a 2 minus, but we have 2 of those. That means that this must be a 4 minus, right? Which means its oxidation here must be, I'm just going to say +4 for oxidation here. So if we have a +4 and a -4, that gives us that 0 that we're looking at, right? So this one must be manganese. Hopefully you know or thought this. 4 oxide. Okay, these do take a little bit of practice. As long as you know your algebra, you know how to balance things out to 0, you're going to be just fine. Okay, we know that chlorine is a -1. How do we know that? Once again, because, yay, we know some of these we can count on, okay, to help us out. So we know this is a -1. Well, it took 4 of these, okay, to balance this out to a positive, to a net overall charge of 0. So if there is 4 times a -1, what will this be? Well, hopefully you said a +4, okay? So this is going to be lead 4 chloride. Okay, so I'll do maybe one more with you, and then I'm going to like you to finish up until 15 on your own. And then we will go over 16 through 30 in class. I'll have you just come up to the board, each one of you take a turn to do some of these. It'll help you out as you go along. And then after we do this classwork part, then you will have some homework, which I'll show you where to find it here in a minute. Okay, so if this one, bromine, let's go check it out. It's over here. We know, we already said that all of these have an oxidation of number of -1. Thank goodness we can save our brain cells a little bit, so that must be -1. We have 2 of them, so that's a -2. That must mean that this is a +2. So that's going to be cobalt to bromide. Okay, hopefully this is enough examples to get you started. You're just going to keep on doing these. Use this periodic table here if you'd like. You can always pause or go back. You're going to have to find out where PT is. It's going to be platinum. We don't know what charge that is, so we're going to have to go and find out something that we do know. Well, we do know sulfide, all of these are a -2 of oxidation number, so this is a -2. Well, we had 2 of those, right? So 2 times a -2 is a -4, which means that this must be a +4. So you would put down platinum 4 sulfide. Okay, you guys have fun with these. I like doing them. I think they're kind of fun, like little mysteries to be solved. So keep on doing these up to 15. Whenever you finish these, again, we will do some of these in class as classwork. For homework, if you recall, we did these type 1 and type 2 compounds. You were supposed to do type 1, and I told you to hold on to this document. So now you're going to do the type 2. Once you complete the type 2, then it'll be due. Just go ahead and turn it in through Canvas. My honors class, you guys, you're due Friday, whenever that is, the end of this week. And then my CP, you guys are due on the 10th. That's next Monday, regardless of what day I have you. Make sure you have that in your calendar, okay? So this should populate automatically to your calendar. Make sure you finish those up and turn those in. I am not taking any late work. Just make sure you guys are doing what you're supposed to be doing and getting this stuff done. Alrighty, I will see you guys next time in class. Work these out, have some fun, and I will see you soon.